So let the recording be started. Okay, it is started. So I'm now starting our discussion today. Is it visible? Can you see?
Yes, sir.
Okay, so we are discussing the load frequency control or frequency control system of power system. Already we have discussed this thing, but in a nutshell, I shall again discuss this or describe this a little bit and then proceed towards the mathematical modeling of the load frequency control system. Already I have mentioned that this is the basically the schematic diagram or simplified functional diagram of the primary ALFC loop. ALFC loop, already we have mentioned, A means it is the automatic load frequency loop. Why this is load frequency control loop? Because frequency control is sometimes known as the load frequency control. The reason is that the variation in load is the reason for the variation in frequency. So whenever load changes, there becomes a difference between the active power generation and the active power demand of the load. So the frequency varies. To make up the frequency, to recover the frequency, what you have to do, you have to change the active power output of the generator. That means you have to supply the active power as per requirement of the load. That's why the frequency control also is called the load frequency control. Okay, and this is automatic because except one point here, as we have discussed and we shall be discussing again today, except one point where we are giving a power increase or decrease command, the whole process of frequency control mechanism is performed automatically. That's why it is called the automatic load frequency control. Okay, and this is the primary ALFC loop. Actually, later on we shall see that there is also a secondary loop of the control system, of the load frequency control system, and this is therefore called the primary load frequency control system. What is the difference between the primary and the secondary loop? That will be clear as we proceed in the discussion. So the heart of the frequency control mechanism, frequency control system, is the speed governor, and speed governor is having two fly balls. These fly balls rotate with the rotor of the generator. So if the rotor rotates at synchronous speed, fly balls also rotate at synchronous speed. Fly balls are connected through a spring, and the speed of rotation of the fly balls therefore determines the tension on the spring. At synchronous speed, the tension on the spring is corresponding to the synchronous corresponding to the tension during the synchronous speed, and this determines the position of the point B here, because with these fly balls, this rod here, rod here, rod here, and this rod here, they are connected in this fashion. They are pivoted at this point and pivoted at this point. That means the with the movement of the fly ball outward or inward, depending upon the speed, you can say these rods may be going up, maybe going down. So as a result, B that is connected with this rod system, what will happen? The B will either go up or it will go down. So at a frequency above synchronous, what will happen? At the frequency is above synchronous, obviously the speed of the fly balls will be above synchronous speed. Tension will be more because centrifugal force will be more. So there the fly balls will be moving away, moving apart. Therefore, B will come down, because if they go in this direction, if this go in this direction, then obviously this can be done by pulling B downwards. So B will come down. Okay. So at synchronous speed, B has a definite position. At a speed above synchronous, point B will move downwards. Similarly, at a speed below synchronous, tension will be less than the synchronous speed tension. So there will be less pull, less tension on the spring. So the flywheels will come closer. In this process, they will push B upward. So B will move upward. So downward movement of B is due to above synchronous operation of the synchronous machine, above synchronous speed operation of the synchronous machine, and upward movement of point B is due to the speed becoming below normal, below synchronous speed. Okay. Now, this point B is connected at B at the pivot of this system ABC. ABC is a rigid system, a rod here, and this rod is pivoted at B. CDE is another rigid link. This is pivoted at D, and this is a hydraulic amplifier. The function is of this hydraulic amplifier is to apply the force. Which force? Any force generated at here at this point, or any force generated here. Okay, this will be magnified by this hydraulic amplifier. What is the purpose? Purpose is to move this or increase or decrease the opening of the steam valve. And this is the passage between the boiler and the turbine. And in this passage, we have the steam valve located. So for increasing the steam flow rate, the valve opening will be increased. For decreasing the steam flow rate, valve opening has to be decreased. So an upward movement of this piston, this is the main piston and this is the piston rod. So upward movement of this piston rod will create a smaller opening of the steam valve. A downward movement will increase the opening of the valve, letting more steam to enter into the turbine. Now you see that this is the hydraulic amplifier. So this hydraulic amplifier, it has two cylinders basically. This is narrower cylinder, this is the larger cylinder. Okay, these cylinders are connected at this point and at this point through these two openings. Now the operation of this hydraulic amplifier is such that at steady state, what is the steady state? Steady state means speed is steady, speed is constant, speed is synchronous. For power system having synchronous generator, when the speed is constant, when the speed is synchronous. So at synchronous speed, at steady state operation, this opening of the hydraulic amplifier cylinder will be closed by this pilot valve. This opening will be closed by this pilot valve because they will be exactly at this location, and at this location their shape is such that, their size is such that this opening will be fully closed, this opening will be fully closed. Now this cylinder is again connected with high pressure oil. What is the high pressure oil pump? What is the purpose of this high pressure oil pump? High pressure oil pump will maintain a pressure, that means maintain a thrust on this oil here, such that oil in this cylinder remains in at stable condition, remains in steady state. It does not move. But and it cannot move also because this opening is closed, this opening is closed. Oil inside this chamber cannot go out. At the same time, oil in this chamber cannot go out, and at the same time, oil in this cylinder here also cannot go out because this is being kept at high pressure by the high pressure oil pump. Now, if the high pressure oil does not move, then can you change the position of E? You cannot, because then for changing the position of E, that means you have to either move this rod downwards or upward. So you cannot do this because oil is not moving. So during steady state, that means when the speed of the synchronous machine is fixed, at that time point E cannot be moved. Because for moving point E, you have to either move the main piston upward or move the main piston downward. So since we are not doing this, since the oil here is at steady state, it is quiet, it is not moving. Okay, it is filled, and this oil pressure, high pressure oil pump is maintaining this pressure here. Then E position of E will not be changed, okay, or it cannot be changed. All right. Similarly, position of A actually represents a certain power output of the generator. And you can either give a power increase command or a power decrease command by moving the point A downwards or upward. And these can be affected by this handle. This handle is basically a speed changer. Why it is called the speed changer? Perhaps I have discussed and I shall be discussing again today. Okay, well, as I proceed, it will be apparent why this is called the speed changer. So basically, this speed governing mechanism has this speed governor consisting of the fly balls, this spring, and this rod system, and the speed changer here, this rigid link ABC, this rigid link CDE, this hydraulic amplifier, and this main piston and the piston rod along with the steam valve. That means the arrangement of passing steam from the boiler to turbine. Now let us see how it operates. Okay, how the frequency is being controlled by this load frequency control system. Okay, let us assume that our generator was running at steady state and it was delivering some power to the power system. And the power system was operating at synchronous speed. Our generator is operating at stable conditions, so the generator is also running at synchronous speed. And at synchronous speed, say a certain amount of power, say P, is being delivered by the generator to the infinite bus. Now what you want to increase the power output of the generator, so you move A downwards because a downward movement of A will raise the power output. An upward movement of A will lower the power output. We are giving a power increase command. We want to increase the power output, so we are moving A downwards is by a step. Okay, obviously actually there what will be there, a number of positions will be there, at each, and each position correspond to a certain amount of power output. The generator was delivering a certain amount of power. Now we want the generator to deliver somewhat increased power, so we have moved A downwards. Now as you are moving A downwards, you see that ABC is a rigid link. Position of B is determined by the speed of the generator, and you cannot change the speed of the generator. How the speed of the generator will change? When there is more power input to the generator, mechanical power input, or when there is some change in load of the generator. So you have no access to that load change. You can increase the power output. How? You can give a command, and you have given that command. But as soon as this command is given, obviously speed of the generator has not changed immediately. So you cannot change the position of B. That means position of B is fixed. So when A is moved down, speed remains synchronous. B cannot move downwards or upwards. So B is fixed at its initial position. So what will happen to C? As A is moved down, C has to move up. All right, is it clear? As A is moved down, C has to move up. All right, as C is moved up, what will happen to D? D also will move up. Why D will move up? Because there is space here so that D can move up. But E cannot move up because for moving E, what is required? You have to change the oil inside this chamber. That means either some oil should go out through this passage or oil should move out through this passage. That is not happening because this is closed, this opening also closed. So since this is closed, E cannot change its position. So as C is moving up, along with C, D also will move up. Okay. So as D has moved up, what has happened? D has moved up means keeping E fixed. So an opening has been created at the lower part of this valve, and an opening has been created again at the lower part of this valve. Means this oil pump is maintaining the pressure here. So as an opening is created here from this chamber, oil will come out through this passage. Through this passage from high pressure oil pump, oil will enter from this small cylinder to this large cylinder, give a thrust on the main piston, and oil is coming out through this passage. So main piston will move down, go down. As the main piston is going down, obviously this rod is moving down. So valve opening is being increased. As the valve opening is increased, what is happening? More steam is entering into the turbine. All right. As the valve opening is increased, an increased amount of steam, that means steam flow rate increases because more steam now can enter into the turbine. So steam flow rate increases. Steam flow rate increases means generator output cannot immediately increase. Means generator output remains fixed because delta is fixed. As steam flow rate is increased, so torque input to the generator is mechanical torque input is increased, but electrical torque output remains fixed at previous value. So there is accelerating torque. There is difference between input and output. Input is more than output means there is accelerating torque. As a result, speed of the generator increases. As speed of the generator increases, delta increases. As delta increases, power output of the generator also increases. Okay. As power, so what happens with the increase in speed? Now see, as the speed is increased, generator is rotating at a speed which is above synchronous. Means flyballs are also rotating at a speed above synchronous. As flyballs are moving at a speed above synchronous, B is coming down. So B will come down, keeping A fixed at its previous position, that means new position, where we have moved A from its previous position. So A will be kept fixed at its new position. Now B will move down, keeping A fixed. So B will move down. As B has moved down, now C will move down somewhat. As C has moved down, what will happen? D also will move down somewhat. So the opening created here may be somewhat reduced. Okay, so this is the process that will take place. That means initially an opening was created. Now that opening will be reduced. Maybe it is not fully reduced. Fully the gap is fully gone. That may not be happening at one step. So, but what will happen finally? Finally, that speed increase, decrease, opening increasing, decreasing, because this is a mechanical system, that type of oscillation will go on. And finally, at new steady state, that means steady state means when the speed again will be synchronous. If the speed becomes synchronous again, then that will be possible when the pilot valve is fully closing this opening here and this opening here. That means the piston will be at a new position. At that new position, opening will be somewhat more than the previous opening, so that now generation from the generator has increased from its previous one. So this is how the system will behave. This system will actually respond as a result of the speed power increase command given by the speed changer. Okay, so you have moved the speed the point A downward is a step by step, and as a result of this movement, what has happened finally, the steam valve opening has increased. As steam valve opening has increased, speed has increased. Because of speed increase, B has moved down, C also has moved down. As a result, D will be moving down, so reducing their previous opening somewhat less here at this connection of the two chambers. Okay, to cylinder of the hydraulic amplifier. So in this way, the system will behave following an increase in the following a command of power increase, command to power increase. Okay, so this is how the system will work. Now you see that whenever you have moved down by a single step, you have given a power increase command. What has happened as a result? As a result, you see that finally the speed of the generator has increased somewhat, and this speed increase is not at the steady state. Previously, at the steady state, generator speed was synchronous. When a new steady state will be reached, then also the speed will be synchronous. But in between, during the transition from one steady state to another steady state, the speed has become above synchronous. And why the speed has become above synchronous? Because of the change in the position of A, and change of the position of A has been activated, has been affected by the movement of this speed changer. Therefore, this this handle that is used to give a power increase or power decrease command is called a speed changer, because it is helping to change the speed of the generator, and obviously that changes in during the transition period only. Okay, that's why this is called the speed changer. So now this is how the system is working when a power increase command is given. Note here that you have given a power increase command, and that means this is the only external input that you could give. But what is happening as a result? As a result, again there is the change in the position of B, change in the position of E, and that is happening automatically. How? Because of the change in the speed, position of B is also changed. So these things are happening automatically. Only the change in position of A has been actually given by the operators. The operator can change the position. So he can either give a power increase command or a power decrease command. Okay. So now is this description of the operation of the system, is it clear or not?
Yes,
Tell me.
sir.
Yes, sir.
Is it clear?
Yes.
So shall I again discuss what will happen if this power decrease command is given or it is not necessary? If you give a power decrease command, what will happen? Shall I have to discuss it or you can understand that?
Sir, we can understand that.
Okay. Now let us now develop a mathematical model of this whole thing, because finally our intention is to analyze the load frequency control system. Okay, how the load frequency control system works, how it should be actually operated. Okay, what has to be done? These things are to be analyzed, and obviously, unless you analyze this whole thing, you cannot understand and you cannot control. So, our intention, therefore, is to develop a mathematical model of this control system, load frequency control system. To do this, let us now see. So these things are what I have already mentioned you. Obviously, I shall send you all these things. You will be having all these things. You can follow this, no problem. Okay. But now come here, where the mathematical model is being developed. Now you see that the movement of C. Now we are developing the mathematical model. So I shall basically follow this and explain this thing with, again, taking the reference of that diagram, of that figure of the that load frequency control system. The movement of C is contributed by delta XA and delta XB. XA is the representing the position of A, XB representing the position of point B, and delta XA represents the change in the position of A. Delta XB represents the point change in the position of B. Similarly, delta XC represents the position of change in the position of C. Delta XD represents the change in the position of D, and delta XC represents the change in the position of E. Okay, so any change in the position is represented by delta of that X. Okay, now coming here, you see that here any downward movement we shall be considering to be positive. That means downward movement of A will make positive change in the position of A. Then downward movement of B, downward movement of D. Any downward movement will be considered a positive change. Okay, positive displacement. Now, how you can change the position of C? XC. Movement of C is contributed by XA, del XA, and X del XC. But how it is being contributed? Whenever A is moved down, what happens? C moves up. That means a negative movement of C is affected when a positive movement of A is taking place, or a positive movement of A creates a negative movement of C. Is it clear? Similarly, if A is fixed, okay, we have seen earlier that if A is fixed and if the speed increases, then what happens? B moves down. So when A is fixed and B is moving down, we have seen that C also is moving down. That means a positive movement of B creates a positive movement of C. So a negative movement of A creates a positive movement of C. or a positive movement of A creates a negative movement of C, and a positive movement of B creates a positive movement of C. So that we can now write delta xc, change in the position of C, is equal to K1 delta F minus K2 delta PC. K1 delta F is due to the change in the position of B. K2 delta PC is due to the change in the position of A. How it is due to the change in the position of A, and how this is due to the change in the position of B. Let us discuss this. Okay. Now we see that K2 delta PC, it represents the change in the position of A. What is delta PC? Delta PC is the power increase or decrease command. How much power has to be increased or decreased? That is represented by delta PC. So delta PC basically is a power, and what power? The power that has to be changed at the output of the generator. Okay. So why you are giving a, why position of A is changed? Because you want to give a power increase or power decrease command. How much the power will be changed? That we shall know from how much movement, how much power will be changed. That obviously will be known from the calibration of this. Okay, that will, but what is the main purpose? You are changing the position of A here. As a result, we are giving a power increase command. So we want to actually develop a model in terms of the power increase command or decrease command, in terms of the change in frequency, and in terms of the opening of the steam valve. So our intention will be to develop the mathematical model in terms of delta PC, that means power increase command, in terms of frequency change delta F, and in terms of the change in the opening of the steam valve. Okay, so you see that change in the position of A, it is better for us because our intention is this, to represent through change in the power increase command. Okay, that's why we are writing K2 delta PC without writing delta XA. Okay, that's why we are writing delta K2 times delta PC. Why K2 delta PC? Because you are changing the position. Delta PC is power. So position means the displacement has to be represented by a change in power there. So a multiplier is needed that will convert distance to power. So it will be some distance by power will be the unit of K2, and therefore that multiplied by delta PC means ultimately a distance. Okay. So is it clear? It is explained why K2 delta PC represent is due, it is coming due to the change in the position of A. Okay, and it is negative because a positive movement of C creates a negative movement of, a positive movement of A creates a negative movement of C. And since we are writing equation in terms of the positive movement of C, then obviously there will be a negative movement of A. Similarly, wow, it is K1 delta F. This is representing the movement of B. Okay, how? How it is representing the movement of B? You see that B, how B position of B may be changed? Obviously, it may be changed by the change in the speed of the flyballs. There is no other alternative. Okay, position of B may only be changed if the speed of the generator changes. All right. So if the generator speed become above synchronous, then B flyballs will move at a speed above synchronous. There will be more tension on the flyballs. As a result, B will come down. That means a positive movement of B will be created. Okay. So positive movement of B therefore is being created by the change in frequency or the change in speed. So since we want to represent it in terms of frequency, that's why we are writing K1 times delta F. Delta F is in hertz. So obviously it is displacement to frequency. Therefore, K1 will have the unit. How much it will be? The unit will be the displacement by hertz. Into hertz will be the displacement. Is it clear? Why we are writing delta xc equal to K1 del F minus K2 delta PC? Is it clear?
Yes, sir. Yes.
Okay. Is it clear? Now let us relate the movement of D with the movement of C and E. Therefore, basically we are now want to relate the movement of CDEE associated with this rigid link. Okay, associated with this rigid link, we shall be writing the expression between delta xc, delta xd, and delta xc. Now you see that initially when delta x, when xc is fixed, why xc is fixed? Because unless there is oil movement, E cannot be changed. So when E remains fixed, then a positive movement of C creates a positive movement of D. That means when C is moved down, D also will be moving down. Okay. Similarly, when C is kept fixed somehow, and if E moves, keeping C fixed, if oil moves here, then also E will be moving. So when E moves downwards, keeping C fixed, then D also will move down. That means with E fixed, downward movement of C creates downward movement of D. Similarly, with C fixed, a downward movement of E will create downward movement of D. That means a positive movement of C creates a positive movement of D. A positive movement of E creates a positive movement of D. So let us write this in this form. Delta XD equal to K3 times delta XC, K4 times delta XC. Okay, obviously delta XT will not be equal to delta XC plus delta XC. This movement will depend upon this one. Movement of XG is dependent upon delta XC. That's why there will be some proportionality constant. So delta XD is equal to K3 times delta XC plus K4 times delta XC. Is it clear? Could you understand?
Yes, sir.
Okay. Now see how movement of D and E are related. Okay. Now let us see how movement of D and E are related. When E may be moved, obviously you see that for the movement of E, what is needed is the oil movement from this cylinder to this cylinder, either through these spaces or through these spaces. And obviously that oil will come from the high pressure oil pump. So basically it is related with the hydraulic amplifier. So we are now focusing on the operation of the hydraulic amplifier. Okay, because we are interested in knowing how movement of E will be affected by the movement of D. Say D has been moved up. Okay, D has been moved up somehow because of movement of C. D has been moved up. So an opening is created here. It has moved up. An opening has been created here. So what will be happening? Oil from this portion, from this chamber, will drain out through these spaces. High pressure oil will maintain its pressure here. As a result, from this chamber, oil will enter into this, give a pressure. Now piston will be easily coming down because the oil below this piston is going out. So it will come down easily. And at the same time, high pressure oil from here will enter into this chamber and finally into this chamber. Okay, just 1 minute. আচ্ছা আমি একটু ক্লাস নিচ্ছি একটু পরে কথা বলি হ্যাঁ 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 হ্যালো আমি ডি সিক্স হ্যাঁ ওই কি আপনি কি এখন আসছেন ও আমার তো ক্লাস একটু দেরি হবে শেষ হতে আপনাকে আসতে হবে এখন আচ্ছা ঠিক আছে আমি দরজাটা খোলা রাখছি আপনি আচ্ছা আচ্ছা জাস্ট sorry. So what is happening? When D will be moved up, an opening will be created here. As a result, from this chamber, oil will be entering into this main piston. So main piston will move down, okay? And oil from here will come out through these spaces below this pilot valve, okay? Now you see that how much will be the movement of E? Who will decide? That means how much the E will move, on what factors it will be depending upon. Obviously, an opening will be created. So it will be depending upon how much oil from this chamber had entered into this chamber. Okay, that means the volume of oil entered will decide how much will be the movement of E. But not only the volume, it will be decided by the cross section of this cylinder, by the cross section of this cylinder, by the amount of opening created by XD, and by the time for which the opening was created. Am I clear? That means oil volume will be depending upon the time for which oil has moved from here to here, and how much was the opening here. Okay, that will decide the oil volume. On that oil volume, how much it will change the position of it, that again will be depending upon the cross section of this cylinder. Am I clear? Could you
Yes.
understand?
Sir, প্রেসারের উপর ডিপেন্ড করবে।
Pressure উপর depend করবে, yes, obviously it will depend upon the pressure, because pressure will decide for how much opening, how much will be the oil transfer from one chamber to another. Is it clear?
ওকে, ইয়েস।
Okay, just 1 minute. Okay, ঠিক আছে, আমি পরে পরে কথা বলে নেব। আচ্ছা, ঠিক আছে, ঠিক আছে। Okay, so all these things will decide, but what the development of the mathematical model, what is important for us now is to understand the relation between xd and xc, because all other critical things or other delicate things we shall be representing now in terms of some constant and all other things. But you see that for the positive movement of E, that means for the downward movement of E, what is needed? An upward movement of D is needed. Okay, so a upward movement, the negative movement of D creates a positive movement of E. So that's why we are writing this expression. So delta XC is created by negative movement of D. That means delta XD. Integration, why it is needed? Because it will depend upon the volume of oil transfer. Volume will depend upon the rate of oil flow, opening created. Okay, and not only volume is responsible, volume at the same time the cross section of that chamber where the main piston is residing. That's why this K5 is coming. So K5 is coming because of that issues I have mentioned. Okay, and integration is because we are interested in the volume of oil transfer. Volume of oil movement is important here. Negative sign is coming because a for positive movement of E, a negative movement of D is needed. So is this relation, the logic behind this relation, writing this relation, is it clear to you or not?
ইয়েস স্যার,
No?
ইয়েস।
Huh? Could you
ইয়েস।
understand? Okay. Is it clear to everybody? So if it is clear, now what we shall do on the basis of these three equations, three expressions, we shall be developing the mathematical model of the speed governing system. The speed governing system basically is a control system, speed control system. And control system, it has been, you have started learning control system because that paper has been initiated, I think. And how we actually for the analysis or for representing control system, we know that we represent control system in terms of some transfer function. Okay, some transfer function we develop for control system, and for the development of those transfer function, what is needed? We have to generally we develop those transfer function in terms of some Laplace transform. Okay, we require applying Laplace transform there. So what we shall be doing here again, we shall be developing transfer function for the speed governing mechanism, for the speed governing system. Therefore, we shall be applying Laplace transform on these three equations. We shall be taking transform of this equation. So it will be delta XCS, delta XC transform will be equal to K1 delta Fs. Generally, we shall be writing capital F of S to represent the transform quantities. Okay, minus K2 delta P of S, we shall be writing. Similarly, delta XDS, we shall write equal to K3 delta XC of S plus K4 delta XC of S. And delta XC of S, we shall be writing K5 integration. What is the transform? It will be integration is, that means if it is derivative, you know how is the transform. If it is integration, what is the transform? So
One by
K5 by S, okay, K5 by S. So minus K5 by S delta XD of S. I mean, is it all right? Okay. So these are the things, these are the equations that will be utilized. Now you put delta XC equal to K5 by S minus of delta XDS. Put the value of delta XDS here. So you will have again delta XCS, bring delta XCS on that side. Again, here is delta XCS, put the value of delta XCS from this equation here, and then you can write expression for delta XCS in terms of what? In terms of delta PC, in terms of delta Fs. Okay, because delta PC is the power increase command, delta Fs, this is the change in frequency. We shall be interested to develop expression in terms of delta Fs and delta PCs. Okay, and delta XCS is the change in the opening of the steam valve. Okay, because then we shall be using this term later on with some other component of the load frequency control system. Therefore, we shall be writing this expression. What is delta XCS? You write this expression. Okay, then manipulate this, modify this, rearrange this in this form. So it will be K2 K3 delta PCS minus K1 K3 delta Fs by K4 plus S by K5. Okay. Then you may write this as equal to delta PCS minus delta Fs into K1 K2 into K2 K3. These things you can rearrange. You can very easily do all these things. Okay, no problem. But finally, what we do, we write transfer function, first order transfer function. How? The general form is some gain divided by 1 plus S into time constant. This is the standard form. So some gain kg here divided by 1 plus S times of Tg. Tg is the time constant of this speed governing system. Okay, kg is the gain of the speed governing system. So kg by 1 plus stg, this is the transfer function of the speed governing system, mathematical model of the speed governing system. And what are the inputs? Inputs are delta PCS and del Fs. So delta PCS minus del Fs by R. This is how we are writing. R, it is coming for K2 by K1. R is called the governor regulation. What does it mean? We shall explain later on, not now. We shall, whenever we shall be discussing more on these transfer functions. Okay, then we shall actually discuss what is the meaning, physical meaning of R. So for the time being, let us simply know the name. R is K2 by K1, and it is the regulation of the speed governor. Kg is the governor gain represented by K2, K3 by K4, and Tg is the time constant of the speed governor. It is 1 by K4, K5. The order of the value of Tg is of the order of 100 milliseconds. This is the order of Tg. Okay, and therefore we can write these things. Sometimes we may write in this way: G of S. G is for governor. G representing the transfer function of the speed governor. G of S, Kg by 1 plus STg, and del PCS, it is the power increase command. Del Fs is the transform of the frequency change, and R is the governor regulation. So this is how we may represent the governor. Okay, in general standard representation form, you know, kg by 1 plus htg representing the transfer function of the speed governing system. Del xcs is the output of this. Inputs are del pcs and 1 del fs. Obviously, it is del pcs minus del fs by r into kg by 1 plus htg equal to delta xcs. So this is the mathematical model or transfer function model of the speed governing system. Is it clear or not? This much, is it clear? Is it all
Yes,
right? Hmm. Now we shall have to represent other things also, because or you have so far only represented the speed governing system. But what else are there in the power system? That means whenever you will be discussing the frequency control, you have to consider the turbine, you have to consider the generator, you have to consider the load, because variation of load creates change in power balance, and change in power balance brings the change in frequency. So generator has to be represented, generator inertia has to be represented, load response has to be represented, and obviously turbine also has to be represented. So let us see how to represent all these things. Turbine, we shall not go into the detailed representation of turbine. How to represent turbine? We shall be representing it, or we shall be assuming a transfer function model for the turbine. We shall be assuming that we are ignoring the reheat. You know that in that steam generation process, there is superheater, there is reheater, there is economizer, and all other things are there. Okay, but if you consider the simplest form of this boiler and turbine system, then that means if we ignore the reheater, then the turbine may be represented by this first order 10 transfer function, and the form is kt by 1 plus s time tt. So we shall assume that this is how it may be represented. That's why, since turbine is a basically actually it is a process of steam generation process, therefore we shall not be going into the details of that representation. We shall be assuming that for frequency control analysis, we shall be assuming that turbine may be represented by a first order transfer function, assuming we are considering only the superheater. If you want to consider reheater, then it will be a second order transfer function. Okay, so second order transfer function will represent the reheater. But for the time being, we want to make or we want to keep our analysis simple, because we want to understand how the things are going on, how the control may be affected. This is our main issue. Okay, we can improve the efficiency by increasing the inserting the reheater in the system. So what is the basic point of introducing the reheater? Obviously, it is increasing the use of heat. More utilization of heat is there, so it is improving the efficiency. So that aspect we shall not be considering now. That's why let us assume that we are considering superheater only, not the reheater. But reheater may be considered if you represent the turbine using the double second order transfer function like this. So for the consideration of superheater only, this will be the simple representation, and for the time being, we shall be satisfied with this representation only. So delta xc, it is the opening of the steam valve. So more steam is entering into the turbine. Okay, if the opening is increased, then this steam is then converting into power. Which power? Now it is mechanical power. Okay, so obviously kt by 1 plus s time tt, it is the transfer function of the turbine, and the time constant is of the order of 0.2 to 2 seconds. Of the order of second is the time constant of the turbine, and delta pg is the power increase. Okay, because of increased opening of the steam valve, this is the power increase. Delta Pg is the amount, delta Pgs is the transform of the power increase. Okay, If we assume that generator is having 100% efficiency, then obviously this is also equal to the electrical power output. Now, if basically this is the at the output of the turbine, obviously it is the mechanical power input to the generator. Okay, so this represents the turbine is first order transfer function, kt representing the gain of the turbine, tt representing the time constant of the turbine. So neglecting the reheater, only by considering the superheater, this will be the representation of the turbine, and we shall be now satisfied with this model only. Okay, now what we have to do? Now let us now consider add these two things. Okay, you see that you had actually the turbine and you have the governor. Basically, actually that is kg by 1 kg by 1 plus s times tg, kt by 1 plus s times tt is the actual model. So here some one is written here, that means kgkt. We have omitted here. Why this can be omitted? I shall explain. Okay, so basically this is the combined representation of turbine and governor. So governor is represented as kg by 1 plus stg. This is the first transfer function of the governor, and turbine is represented by kt by 1 plus stmtt. It is the transfer function of the turbine. So at the output, it is delta PGS, power increase at the input of the generator. Del Fs is the change in the frequency. Okay. R is the regulation of the governor. R is the regulation of the governor. Then del PCS is the power increase command, transform of the power increase command. Okay. Now, at this stage, before we represent generator and load, and the total power system, we shall now investigate into some of the operation of the this turbine and generator together. Let us see how these two may be analyzed when the system is connected to power system. Let us assume that we are analyzing the governor action. Okay, governor as well as turbine. Turbine is there. Now, how the governor is operating. Okay, so we shall try to find out the meaning of that R, governor regulation I have mentioned. That's why we are making this analysis here. Let us assume that generator is connected to infinite bus. What does it mean? When the generator is connected to infinite bus, obviously, how much will be the change in how much will be the change in frequency? What will be the value of del Fs if the generator is connected to infinite bus?
Zero, I think.
Zero. That means, first of all, now assume that we have a generator. It is a governing system. Obviously, it is the turbine, and this generator is connected to infinite bus. So when it is connected to infinite bus, automatically you know that there is no change in frequency. Means del Fs is zero. Since del Fs is zero, what is the relation between the power increase command and power output of the generator, or power mechanical power input to the generator? We can say that this is also the power output of the generator, provided the generator is represented by a transfer function of equal to 1. আপাতত আমরা ধরে নিচ্ছি সেটা। ওকে, যদি তাই হয়, then what is the relation between the power increase command and power output command? Power output, it is del PGS, power output. Okay, this is equal to kg kt by 1 plus s time tg and 1 plus s time tt. Okay, into del PCS. This is the relation. Okay, so del PGS equal to kg kt by 1 plus s time tg into 1 plus s time tt into del PCS. All right. Now, what is del PCS? Del PCS is the transform of the power increase command. So you want to increase the power output of the generator. That's why you are giving a power increase command. Say power initially power output was 100 megawatt from the generator. Now you want that generator should deliver 120 megawatt. So what is delta PC? Delta PC is equal to 20 megawatt. So there is a step change in the output of the generator, 20 megawatt. So what should be the value of delta PCS? It will be delta PC desired change by S Am I clear? So power increase command basically it desires a step change in the power output of the generator. Okay, so it is a step input basically. You are giving a power increase command. So what type of input it is? It is step input. So if it is step input, delta PC is the magnitude of change. What will the transform of this delta PC? It will be delta PC by S. That means delta PC S equal to delta PC by S. Is it clear?
Yes, sir.
Huh?
Yes.
Delta PCS. So if this is delta PCS, what is delta PGS? Put the value of delta PCS here. Put the value of delta PCS here. Now, following a following a power increase command equal to delta PC, okay, how much will be the change in the power output? What will be the final value of the change in power output? Obviously, we shall have to take the help of the final value theorem. Okay, what is the final value theorem? Will be final value of delta Pg may be found out by writing S times delta PGS with S limit S tending towards 0. Okay, this basically is the final value theorem. So you write S times delta PGS and make S tending towards 0. So it is Kg Kt delta Pc, S and S will be cancelled out, Kg Kt delta Pc. As S is tending towards 0, this will be totally 1, this will be equal to 1. So del Pg static means steady state value of delta Pc. Steady value, final value of delta Pg will be, it is represented by del Pg stat. Okay, static. From static it is stat, will be equal to Kg Kt delta Pc. Alright. So kgkt delta PC is the change in power output corresponding to the power increase command delta PC. So you have given a power increase command of say 20 megawatt, but how much power output you are getting? You are getting 20 megawatt multiplied by kg and kt. So if your desired power output is 20 megawatt, what should be the value of kg and kt this product? It has to be equal to 1. Am I not? Am I not correct? Is it clear? That
Yes,
means
sir.
what delta Pg stat is coming, it is equal to kg kt into delta Pc. Okay, that means obviously you have given a power increase command of 20 megawatt. So you should get or you should expect that power output, change in the power output also will be 20 megawatt. So in that case, what should be the value of kgkt? So this product should be set. That means you have to adjust this value, okay, such that kgkt this product becomes equal to 1. That's why we have actually here we have written in this way. So what will be the product kgkt? That will be equal to 1 such that del pg stat becomes equal to del pc. All right. So what we have actually observed here, so you have to set kgkt product equal to 1, and if you set kgkt product equal to 1, what will happen? If you connect a generator to a large power system, a small generator connected to a large power system, it is equivalent to a generator connected to infinite bus, because with respect to the power system, capacity of the generator is very small. Then we say that that power system is behaving as an infinite bus to the generator. Okay, so when you connect a generator to a large power system, means an infinite bus, any change in the output of the generator, we assume that there will not be any change in the frequency of the system. So if it is true, then what will happen? Any increase in the power input to the generator will create an equivalent amount of increase of power output of the generator. So if you give a power increase command, if you increase the opening of the steam valve, what will happen? There will be a corresponding increase in the output of the generator only, without any change in the frequency or any change in the speed. That means at steady state there will not be any change in speed. During intermediate period, obviously there will be change in speed, because otherwise how the output will change? Because for change in the output of the generator, delta value has to be changed. Okay. So when we say that there will be no change in frequency. We are talking about the steady state condition, not about the dynamic situation, not about the transient situation. Is it all right? This clear?
Yes,
Could you
sir.
understand?
Yes.
Clear? So, from this analysis, we see that when a generator is connected to infinite bus, that means a small generator, when connected to a large power system, if you make any change at the input of the generator, there will be an equivalent change in the output of the generator. Okay, any increase in power input will create an increase in the power output. All right. So this is one extreme situation we have considered because we have assumed that generator output is changing, generator input is changing, but generator frequency is not changed at all. This is our assumption. Obviously, this is an assumption. This is not the actual situation. This is an ideal situation. What is the actual situation? We shall see this later on. For the time being, let us consider the ideal situation. So, this is one situation we have explained. Now, for understanding the behavior of the governor. So, what the governor is doing here, you are you have changed the speed changer position of the governor. As a result, governor has changed the output of the generator. This is how the governor is operating. Now, consider the other extreme operation. Okay, what is that other extreme operation? Let us assume that now the generator is not connected to power system, rather it is connected to an isolated load. Generator is isolated, it is supplying a load only. Okay, it is connected to terminal load. All right. So and that load is a resistive load. That means it is not frequency sensitive. This is our assumption. The load is such that it is not frequency sensitive, so it is a resistive load. Okay, so under this assumption, what you can say and assume that we have not changed the position of the uh, speed changer. Okay, and any change in the output of the generator will be due to the change in load only. Okay, so that means this condition you consider uh, this one. So now del PC this remains fixed. We are not changing the input of the generator. Okay, but this is changed. How this is changed? Whenever you are connecting some load, obviously the output power will change. Why the output power will be changing? Because now the generator is not connected to infinite bus, it is connected to load only. So as you are connecting, say initially generator was at no load condition, so you have connected some load at the terminal of the generator. All right. So what will happen? The generator, you are not changing the input. So any change in the output now, because you have not changed the speed changer. So that means the operator is not changing the speed changer position. But what will happen? Initially generator was running at synchronous speed. A load and the load was zero. Now a load is connected. Whenever a load is connected, what will happen? Obviously the speed of the generator will decrease and generator governor will sense this change in speed. As a result, it will change the opening of the steam valve on its own. Okay, generator's governor is having this ability. How? When the speed changes, then what will be happening? The point B will be changed. As point B is changed, C will be changed, D will be changed. When point D is changed, obviously oil will enter into the chamber having the main piston. So what will happen? The main piston position will be changed. As a result, valve opening will be changed. So this type of change of valve opening, okay, because of governor action only, this is possible. Okay, governor can do this. All right. So governor on its own, because of load change, will be changing the opening of the steam valve. As a result, output of the generator will change. So what we want to investigate now is that if the output of the generator is changed by connecting more load, how much will be the change in the frequency of the generator? How much will be the change in the speed of the generator. This is what we want to investigate. Am I clear? And this operation, you know that because obviously you have studied this boiler and turbine, this thing, either you have studied or you are studying now. This is called the throttling operation, throttling of the speed governance system. That means you are not changing the opening of the steam valve by giving some external input, but because of the change in the loading of the system, loading of the generator, the terminal of the generator speed is changing. Because of changing the speed of the generator, now governor valve opening is being changed, and this changes by the throttling operation. The governor, it is so called. Okay, so what you will see that speed changer position is not being changed. So what we can write? KGKT product we have set equal to 1. So we can now write that del PGS from this relation. Del PGS, we may write this is 0. Del PGS equal to minus del Fs by R into 1 by 1 plus STG, 1 by 1 plus STT. This is what we should be writing. So here, this is writing here. Del Fs by R, 1 by 1 plus STG, 1 plus STT. This is the relation. Del PCS now is equal to 0 because we have not given any power increase command. So how much is del FSR? That means if power output changes, how the power output changes, that obviously is not obvious from here because power output will change if some load is connected. So we are connecting some load at the terminal of the generator. As a result, del PG is changing. Okay, that much we have to mention here because this is not obvious from the equation here. Okay, so if you connect some load, as a result, how much will be the change in frequency or change in speed? If you connect some load, so generator will generate more power. How it will be generating more power? Because there will be changed steam flow rate. Why the steam flow rate will change? Because of the throttling operation of the governor. Okay, it is because the governor operation only. Okay, governor on its own can do this, and this operation of the governor, when the speed changer position is not moved, not changed, it is called the free governor operation. Okay, that means governor is free to operate on its own. This is called the free governor operation. So because of this free governor operation, how much is the change in frequency following some connection of the load, and connection of the load will make the output of the generator to change. That is represented by delta PGS. So this is equal to minus R, this is governor regulation, we shall explain it, into 1 plus S time TG, 1 plus S time TT into del PGS. Is it clear? This much? Could you
Yes.
understand this?
Yes.
Okay, you could understand this. Now, let us again try to understand. Say, we have given a step change in power output because you will be connecting some load, and say that load is basically a physical load. So what you have done, some load was connected by the application of a switch. A switch was previously open, now we have closed the switch. Okay, for simplification, say that load was equal to the full load capacity of the generator. That means initially generator was supplying no load, output was 0. Now you have connected a load at the terminal of the generator, and what is the magnitude of that load? That is equal to the rated capacity of the generator. That means generator will be actually delivering full load when previously it was delivering no load, 0 load. So output changes from 0 to full load condition. Maybe it is from 0 to half load, maybe it is 10% of load, but for simplicity, okay, for simplifying the analysis, let us assume that it is equal to the full load capacity of the generator. Okay, so if it is, so what is the nature of the load change? It is step change again. There was no load, suddenly a load is connected by the application of a switch. So obviously there is a step change in the output of the generator. Okay, and you may a question may appear in your mind. Then the generator was delivering no power. There was very little steam flowing. What is the purpose of the steam? Obviously to rotate the rotor only and supplying the no load loss only, nothing else. Now, how could the generator deliver this much of power? This much of power it can generate because we have described the function of the speed governing mechanism. Means when the speed of the generator changes, position of B will be changed. Accordingly, position of C will be changed. Position of D will be changed. As a result, E will be changed. And as E is changed, opening of the steam valve will be changed. This operation on governor on its own it can do this operation. This is called a throttling operation of the governor. So because of the throttling of governor, there will be more steam entering into the turbine. As a result, there will be more power generation. And if this power is generated because of a step change in the load, we can say that delta PG now we may write equal to delta PG stat by S. Delta PG stat means finally how much will be the change in output. That is, we are writing delta PG stat. And since this is a step change, it will be delta PG S will be equal to delta PG stat by S. Okay, is it clear? Now, what is the value of del Fs? Put the value minus R 1 plus STG 1 plus STT del PG stat by S. We want to know finally what will be the change in frequency following a step change in power demand or following a step change in load. How much will be the final change in frequency? Okay, because obviously if the generator power deliver more power as a response to connection of load, speed of the generator will change. Then how much will be the change in speed? That we want to know. At steady state, del F stat. Again, from the final value theorem, you can find out. It will be limit s tending towards 0, SFS. So write the value of delta Fs multiplied by S, and limit will be for s tending towards 0. You put it here, the value will be delta F stat equal to minus R into delta PG. Okay, del F stat, what is the value? Minus R delta PG. Means del F stat by delta PG stat means del F stat means steady state change in the frequency at steady state. Del PG state means change in the power output at steady state. Okay, initially it was 0. So how much power is being changed? It is equal to del F. It may be equal to the full load capacity. It may be equal to the 50%, maybe 10%, maybe 12%, whatever it may be, no problem. For analysis purpose, for simplifying the analysis, let us assume that it is equal to full load capacity. So it is, if it is equal to full load capacity, then what del F will represent? Del F will represent how much will be the change in frequency. Okay, how much will be the change in frequency if power output is changed from no load to full load? Who will represent that? That will be represented by R, because this ratio is equal to minus of R. Why minus of R? Because an increase in the value of P when del Pg is positive, then change in frequency will be negative. That means frequency will decrease following an increase in output. Frequency will increase following a reduction in output. That's why it is a minus sign. And you see that this R, that is because of this minus, you see that this nature is grouping in nature. So basically this actually is following a straight line. Del F, del PG, this relation, this is representing the characteristics of the governor now. Okay, when the frequency is allowed to change, system is such that the frequency is allowed to change. Why the system is such? Because we are considering generator connecting a terminal load only. So now from this we can understand the response of the governor. We can understand the characteristics of the governor. How is it is having a grouping characteristics like this. Okay, here it is representing the percentage change in output. It is representing the percentage change in frequency. Percentage change in output, percentage change in frequency. Okay, when output is 0, say this is the frequency high. As you are increasing the output, okay, say 100% is the change in output, then what will be the change in frequency? 100% is the change in frequency. Say from here, say it was 104% was the frequency, now it becomes 100%. when load becomes 100%. This is how we plot it. Okay. So basically R is representing the percentage change in frequency from no load to full load. Why we are talking about for no load to full load? Because of this minus R, and we are representing the value of R with respect to the full load operation of the generator. That means when the generator is fully loaded, and previously it was loaded at zero, that means from no load to full load, this is the change in output of the generator. So how much is the change in the output? Is 100%. That means for 100% change in power generation, how much will be the percentage variation in frequency, percentage change in frequency, that is represented by R. Am I clear? So that's why we are talking, we were saying that del Pg is equal to the full load capacity. Why we are saying this? Because if it is full load, then we can represent R in terms of its capacity. That means if the generator is loaded from no load to full load condition, generator load is changed from no load to full load, that means 100% loaded. Then that means if the output varies by 100%, how much will be the variation in frequency? And that will be R percent. So R percent of F will be the change in frequency. Though this regulation therefore represents the percentage variation in frequency if the generator is loaded from no load condition to full load condition. And since it is linear, it is applicable for any loading of the generator. If it is 10% loaded, then the percent variation will be same. Okay, you will be calculating how much was the frequency for this much of change in load, what will be the new load, new frequency, that you can calculate. So basically, this represents the characteristics of the speed governing system. It is having a drooping characteristics because of this expression here. It is minus R, and if we plot, we are given some representative value here. That means if R is 4%, you can say, then from no load to full load, this variation in load, the variation in power output will be 4%, like this. Okay, is it clear?
Yes,
Yes, sir.
sir. So change in frequency means change in speed, but how a synchronous generator will rotate less than or more than the synchronous speed? You are saying the
Yeah.
frequencies change. That means speed also.
No,
change.
can you please repeat the question?
Sir, here you said that del f stat মানে ফাইনাল ফ্রিকোয়েন্সি চেঞ্জ মানে ফাইনাল যে চেঞ্জের ফ্রিকোয়েন্সি সেটা তার ফ্রিকোয়েন্সি চেঞ্জটা রয়ে যাবে, তার মানে এখানে স্পিডটাও স্যার চেঞ্জ হবে, মানে ফ্রিকোয়েন্সি চেঞ্জ আলাদা করে হচ্ছে।
Because speed change, obviously. Now you see that when say you what we are discussing now, we are discussing a situation when generator is connected to terminal load. That means we are not connected to infinite bus. Am I clear?
Yes,
That
sir.
means now we are assuming that our system frequency may change. This is our assumption. So if the system frequency may change, that means we are allowing frequency to change. Previously, we have considered the generator connected to infinite bus. Okay. In an infinite bus means there are so many generators connected.
Yes,
All
sir.
right. So there was a question of maintaining the synchronism. Now you have a generator. It is connected to terminal load. So you need not maintain the synchronism here because you have only one generator. For the
Yes, yes.
for the issue we are discussing here, you are having a generator only that is connecting to terminal load. So you need not have to bother about the maintenance of synchronism because
No, sir.
since you are increasing the load, generator speed will be changing. That is being allowed here. Okay. That's
Mhm.
why we can represent the change in frequency here. Am I clear?
Yes,
Okay.
yes.
Okay. So this is therefore this much, and I shall have to explain this in greater details. But since there is another program now, it will be starting. So I shall have to stop here today, and rest of the things we shall discuss from here in our next class. Okay. I shall be sending all these things here. I understand that here I should explain some more thing because some more things are to be discussed here. Otherwise, it will not be completed. But Those discussions we shall be making in the next class. Could you understand? Because we have to
Yes.
stop today because I have another program now. There I have to join now. Okay.
Okay, sir. Thank you, sir.
So again, some more things are to be discussed. So let us discuss all those things in our next class. And for today, let us stop it here and see. Let me see how many of you are present now. So Aditya Rai,
Yes, sir.
Aditya is present. Ali Hamzan,
Yes, sir.
Omrita,
Yes, sir.
Ankit,
Yes, sir.
Orijit,
Yes, sir.
Arnav,
Yes, sir.
Devargho,
Yes, sir.
Dia,
Present, sir.
Jishan. Jishan is present. Okay. Kaushik.
Present, sir.
So Shakib.
Present, sir.
Then Shankho.
Yes, sir.
Shayon.
Yes, sir.
Rahman.
Yes, sir.
Present, sir.
Yeah. Shreyas.
Yes, sir.
Shayon is present. Okay. Shreyas is present. Rahman is present. Then Shoel. Shoel. Somnath.
Yes, sir.
Then Shaugato.
Yes, sir.
Shubhasri. Shubhasri. Supratim.
Yes, sir.
Ujjal.
Yes, sir.
Okay. So anybody who could not respond, Sohail, yes. Sohail and Shubhasri, are you present? Shubhasri is not responding. I don't know whether she is present or not. Okay, thank you. So again, we shall be discussing. Who is Muhammad Shual is present. Okay, you are present. And then today is Thursday. Next Tuesday we shall be again discussing. Okay, thank you.
Thank you, sir.
Thank you.
Thank you, sir.
Okay.